We love what we do here at the Cyberwire and are proud to be able to provide the news and insights that leaders and decision makers rely on every day. Our sponsors help us keep the lights on, and if your company would also like to reach our influential audience of nearly 250,000 unique listeners each week, we would love to show you how. Contact us today at thecyberwire.com/sponsor. That's thecyberwire.com/sponsor. And thank you.
Welcome to the Cyberwire's Research Saturday podcast, brought to you in part by Collide, endpoint security powered by people. Hello, everyone, and welcome to the Cyberwire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down threats and vulnerabilities, solving some of the hard problems of protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
Been really focusing a lot on the adversary's leveraging of the cloud. And so we were very curious to know how the adversary maybe is starting to look towards cloud environments as a primary place to start pivoting into their threat vectors.
That's Scott Fanning. He's Senior Director of Product Management at CrowdStrike. The research we're discussing today is titled LemonDuck Targets Docker for Cryptomining Operations. And now, a word from our sponsor, Collide. Collide sends employees important, timely, and relevant security recommendations for their Linux, Mac, and Windows devices right inside Slack. Collide is perfect for organizations that care deeply about compliance and security, but don't want to get there by locking down devices to the point where they become unusable. Instead of frustrating your employees, Collide educates them about security and device management while directing them to fix important problems. Visit collide.com/researchsaturday to sign up today. That's KOLIDE.com/researchsaturday. Enter your email when prompted to receive your free Collide gift bundle after trial activation. And we thank Collide for sponsoring our show. If you've spent a lot of time and money fighting automated attacks but still feel like you're losing the battle, you're not alone. The truth is, bad bots adapt in seconds and evade expensive, difficult-to-maintain defenses. Now there's a better way with Casada. Casada has flipped the script on bots, ending the game of whack-a-mole. Casada's elegantly simple yet superiorly effective approach puts the burden where it belongs, on the attackers, not your business. Stopping bad bots for good. Casada takes just 30 minutes to deploy and shuts down malicious automation in real time with no manual setup, no annoying CAPTCHAs, and no complex rules to manage. Casada stops the bot attacks others can't. Start today with a free instant test at casada.io/cyberwire. That's KASADA.io/cyberwire. And we thank Casada for making it possible to bring you Research Saturday.
Crypto mining has been around for a while. It takes advantage of GPU, graphical cards, video cards like your NVIDIAs and AMDs and such. Takes advantage of compute cycles to generate cryptocurrency. Normally. And this is done for legitimate reasons, for Bitcoin generation. People do it all the time. But it also can be used for not so good purposes because of the anonymity principles around Bitcoin. So in this particular case, it uses a Bitcoin called Monero, which is a Bitcoin mining technology that doesn't actually take advantage of your GPU. It actually leverages regular old CPU cycles to be able to do that.
And in this case, the threat actors are targeting folks who are using Docker instances?
Yeah. So, Docker is a very popular containerization technology. It allows you to run microservices in public clouds or in private clouds. And, to be able to operate these things, they have APIs. And these APIs, in this particular case, are exposed to the public. The adversary is able to scan the environment, find these public APIs, and then take advantage of them.
I see. Well, let's walk through this together. I mean, how did this initially come to your attention?
So we've been doing a lot of primary security threat research at CrowdStrike. We always have, and we've been really focusing a lot on the adversary's leveraging of the cloud. Although the cloud is definitely more secure, it has infrastructure taken care of by the cloud providers. A lot of that security is also a shared responsibility. And so we were very curious to know how the adversary maybe is starting to look towards cloud environments as a primary place to start, pivoting into their threat vectors versus just on-prem. And we were just doing some research, setting up some honeypots, and seeing what the adversary was doing, and we noticed this.
Well, tell me about LemonDuck. I mean, that's the group here. What do we know about them coming into this?
So LemonDuck is a botnet. It's been around for some time. It traditionally would target Windows and Linux machines, and it primarily uses a series of proxy servers to masquerade not only their intent but also the wallets of the Bitcoin mining operation. So it's a fully anonymous botnet that allows you to kind of reach people out. Anything that quacks is a target, and basically allows you to do command and control over various instances and workloads and such.
Well, let's go through it together here. I mean, how would someone find themselves a victim of this?
Well, I mean, typically you would find these things. It's very well masqueraded. So it starts off, obviously someone has found these open APIs, and then basically puts in a small file that basically then loads the crypto miner. It's usually you'll see XR as a process name, but basically it will reach out, download the file. It tries to disguise itself. Initially, it'll look like a PNG file, which makes very little sense, but it comes out as core.png, downloads the file, and then it executes a script, grabs the actual crypto miner payload, which is also masqueraded, and then it starts to execute. And you'll notice this because CPU utilization on these Docker containers will start to rise. You'll also see it do some pretty interesting things in terms of not letting anyone else crypto mine on those instances as well.
Yeah, that was something I noticed in your research here, is that one of the things it does is it kind of cleans house and tries to get rid of any other potential crypto miners.
Yeah, I mean, they want the CPU cycles all for themselves, right? So, they'll look for different process names and kill their competition. It will also disable some monitoring services on Alibaba Cloud. There's a monitoring service that it explicitly finds and then turns it off, and then it's able to do its thing. So yeah, it kind of just cleans the kitchen to cook the duck.
Yeah. Now, in terms of CPU usage here, does it show any sort of restraint here to try to not draw attention to itself, or does it pretty much, hit the accelerator pedal down to the floor?
We've noticed that it doesn't really, because it's in a virtual environment, in a containerized environment. If you look at it from a host perspective, it might not look like it's using a lot of CPU. But if you look at the actual Docker container itself, we've seen it, put on the gas pedal there pretty hard. So it's not super quiet, but it is definitely, takes advantage of what it has in front of it.
And you point out that it's making use of XMRig for the actual mining?
That's correct.
Yeah. Can you describe to me, one of the things that you mentioned here is a crypto mining proxy pool. What exactly is that? So,
a proxy is basically a way to abstract one IP address, and then behind it is a bunch of more sophisticated IP address network and routing capabilities. So basically, it's a pool of these proxies that in the back end is connected to various wallets that it's able to move the cryptocurrency contribution into. It does a couple of things. It lets you masquerade the actual connection, right? So it's standing in the way of you seeing that, but also it allows it to scale. as well. So, it's like any good service provider. It makes sure it provides the service at scale with some anonymity.
Now, for someone who's fallen victim to this, is this a case where if they had something set up to keep an eye on their CPU usage, that could signal them that something's awry, or would they get an unhappy surprise when they got their bill at the end of the month?
Sadly, it could be. You could see your bill go up a little bit. Basically, it's really going to be about actively looking for, unusual CPU utilization that's happening in your Docker containers. And then, of course, providing, some tools to be able to understand, what your process trees are looking like in terms of executing that job, right? So, although it does disguise itself, at the end of the day, you do see XRRig operating in there. So you'll see a process that runs, pretty obvious, called XR, that allows you to know, hey, it's probably the XR rig.
And in terms of sort of spreading out here, it tries to make use of some lateral movement.
Yeah. So like all things of nature, it tries to find a way. So it'll look for SSH keys on the local file system, and then if it sees those, it will try to laterally spread to somewhere else, connect, and provide the same dropper and bring in the miner.
So in terms of mitigation and prevention here, what are you all recommending?
Well, it always comes down to best principles here. You should first of all, don't expose your cloud resources to the internet, right? So use zero trust policies and principles to isolate that. Make sure your API usages are authenticated. Configure Docker and Kubernetes runtime. Only look at signed images from a trusted registry. You may want to take a look at your shift left strategy. How your developers are building their images. Make sure mining software or SSH keys aren't part of your build images as well. Many scanning tools will provide that capability. Again, authenticate those APIs. Just like any APIs that are public, if they're available, to the public, they're going to be found. It didn't take very long for the adversary to find these ones. And then, of course, monitor for your workloads for any kind of rogue containers or high CPU utilization. So, it just gets down to, keeping vigilant.
It strikes me that ransomware really, it is sort of the loud element in the room here. But crypto mining is still active and taking place out there. And this is a sign of that.
Yeah, why do bank robbers rob banks? Because that's where the money is. So I think in this case, as long as there's free real estate for an adversary to take advantage of, and they feel it's a victimless crime, then they're able to monetize that. And LemonDuck makes it very, very simple to be able to do that. The infrastructure's been there for some time, and it's just found a new place to generate currency.
Our thanks to Scott Fanning from CrowdStrike for joining us. The research is titled LemonDuck Targets Docker for Cryptomining Operations. We'll have a link in the show notes. Thanks to Collide for their sponsorship. If you have Slack, Collide is the perfect solution to improve endpoint compliance while educating your employees about device security. Try it out for free at collide.com/researchsaturday. Thanks to Casada for their sponsorship. Casada stops the bot attacks others can't. Start today with a free instant test at casada.io/cyberwire. That's kasada.io/cyberwire. The Cyberwire podcast is proudly produced in Maryland at the startup studios of Data Tribe, where they're co-building the next generation of cybersecurity teams and technologies. Our amazing Cyberwire team is Liz Irvin, Elliot Peltzman, Trey Hester, Brandon Karpf, Eliana White, Puru Prakash, Justin Sabi, Tim Nodar, Joe Kerrigan, Carol Terrio, Ben Yellen, Nick Valecki, Gina Johnson, Bennett Moe, Chris Russell, John Petrick, Jennifer Iben, Rick Howard, Peter Kilpie, and I'm Dave Bittner. Thanks for listening. We'll see you back here next week.